base of a number is what we shall be calling, or is what we call, sorry, let me start afresh. Okay, so as I had told you that we shall be dealing now with numbers which have powers, or numbers which are raised to powers. So for example, if you have a number like 3 to power 4 as we are given here. So this 3 here, this 3 is what we call a base, and then the power of which 3 is given is what we shall be calling, an index. So an index is what we shall be calling an index. So basically, the name indices is got from the word, from the power, or which we refer to as an index. So an index, or a power of any number, represents the number of times that number is multiplied. So for example, if you have 3 to the power of 4, the index of 3, or the power 4, means that you multiply 3 4 times. Multiply 3 4 times. So it will be 3 times 3 times 3 times 3. So if you have 2 power 5, as you can see here, if you have 2 power 5, it means you multiply 2, or you multiply the base 5 times. So it will be 2 times 2 times 2, 5 times. If you have 5 power 4, it means that you multiply 5 4 times. So it will be 5 times 5 times 5 times 5. That is 4 times. So the same thing, if you have an unknown a to the power of 7, it means you multiply a 7 times. Please, in case you have a question, feel free to unmute yourself and ask. As I go on, in case you have a question, feel free to unmute yourself and ask. So meaning that if you have b to the power of 2, this means that it will be the same as b multiplied by b, or you multiply b 2 times. So they are what we call the laws of indices. So numbers which have bases and powers have laws that govern them. So those laws are what we call the laws of indices. So let us first look at the first law, which we call the multiplication law. So according to the multiplication law, if you're multiplying 2 numbers with the same base, for example, I'm multiplying a power 2 multiplied by a power 3, you realize that the base is the same. This one is the same as this one. The bases are the same, and these two are called the base. So since the bases are the same, the law of indices tells us that when we are multiplying numbers with the same base, we keep the base the same, and then we just add the powers. So it will be a power 2, it will be a power 2 plus 3. So if the bases are the same, keep the base but add the powers. So we shall end up getting our answer as a power 5. That is when the bases are the same. So look at this. They've also shown it to you here clearly. If you have a power 2, this means a times a. And if you have a power 3, this means a times a times a. So this will be a times a times a. If you remove the brackets, times a times a. And the answer is a power 5 here. So you realize that it is the same, but the law says that keep the base the same and then add the powers. So that's what they are trying to show us here. So the index of the product is the sum of the given indices. That's what they are trying to show us. So if you have a power m times a power n, you keep the base the same, and then you add the powers, as you can see here, as you can see there. So let's look at some of the examples. If you have 4 power 2, and then you multiply it by 4 power 3. So if we try using the laws of indices, this will be given by 4. Since this has a base of 4, and this also has a base of 4, so keep the base and then add the powers. So here it will be 2 plus 3, and we end up getting our answer as 4 to the power of 5. So that is what we call the first law of indices. So, or that is the law, the multiplication law of indices. So let us look at the law of division. The law of division. So according to the law of division, if you're dividing two indices, for example, you have a power m, and then you're dividing it by a power n. A power m divided by a power n, or this can also be written as, or if you are dividing indices like this, a power m divided by a power n. So what you do is that, according to this law of indices, you see if the bases are the same, you keep the base. So you keep the base, and then you subtract the powers. So it will be a power m minus n. So this is the division law of indices. So when you are dividing two index numbers with the same base, you keep the base and subtract the powers. So a good example is given here. If you have a power 5 divided by a power 3, this will be, if you do it without using the laws of indices, it will be a times a 5 times divided by a times a 3 times. So you'll end up remaining with a power 2. But if we use the law of indices, this will be a, then if we use the laws, to mean we subtract the powers, which is a power 5 minus 3, and 5 minus 3 is 2, so we shall get our answer as a power 2. A power 2. Okay. Any questions before I continue to another law of indices? Tobisi and Gnidza. Do you have any questions before I continue to another law?
Yes, I got you.
Yes?
I get you, so you can continue.
Okay. I'm seeing someone coming, and but he's not joining with audio. Let me first help to join with audio a bit. Please, a minute. Let me first help this one to join with audio. Where is my Word document? Where's my Word document? Okay. Yeah, hope is able to see that. Hope is able to see that. Okay. Okay, let's go back to our lesson. So we move on to the next law. Let's move on to the next law. So if I move on to the next law, the next law is the law of powers. So according to the law of powers, when you're multiplying indices, for example, if you have an index which is like a power 2 multiplied by a 3 outwards, basically this is the same as having is the same as having multiplying a squared 3 times. It's like a squared times a squared times a squared times a squared. Okay, let me first mute someone, I think. So in case you want to ask, you'll unmute yourself. Okay, so that is what it means. So this will be, remember here, if we now apply the law of multiplication, where we have to add the powers, it will be 2. That was the first law that we looked at, plus 2, plus 2, plus 2, and we end up with a power 6. But according to the law of powers, it says that when we have something like this, we just keep the base constant and just multiply the powers. So according to the law of powers, it tells us that if you have something like this, what you do is that keep the base and then just multiply the powers. So it will be 2 times 3, and you end up getting your answer as a power 2 times 3, which is a power 6. So that is what the law of indices, the law of powers says. So basically we have these three are what we call the basic laws of indices. So in all the questions that we shall be doing, all the questions that we shall do, we shall basically involve those three laws of indices in whatever we shall be doing. Whatever we do, we shall involve the 3 laws of indices. So let us look at some questions now. Let's now shift to questions. Questions. So we have a question here. This is the question. So it says, work out 2 power negative 4 multiplied by 2 power negative 5. Maybe as a reminder, before we answer the question, we have what we call negative powers. Maybe I can look at it here. We have what we call negative powers. Negative powers. So negative powers. So let us look at what basically happens when a power of a number is negative. So the negative powers, this is what they mean. If you have a number like a, I've written it poorly. Let me first erase it and try writing it. If you have a number, like a power negative m. So you can see that the base a has a negative power of m. So this one here means that it is 1 out of a power m. That is what a negative power means. A power negative m means 1 out of a power m. That's what a negative power means. So it means that if I have a number, let's say like 4, if I have 4 power negative 2, this is the same as having 1 out of 4 power 2, which can also be given as 1 out of course, 4 power 2 means 4 multiplied by 4, which is the same as 1 out of 16. So that is what it means. A negative power means this is the same as 1 out of that number with a positive power. 1 out of that number with a positive power. So let's go back to our questions here. So the first question tells us, work out 2 power negative 4 multiplied by 2 power 5. Work out 2 power negative 4. Work out 2 power negative 4 multiplied by 2 power negative 4 multiplied by 2 power negative 5. So when answering such a question, this is what we do. So when answering such a question, we do this. One, we use the laws of indices. Remember, the first law of indices says if you have A, let me go back to the laws briefly. They are here. The first law is here, which is the multiplication law. It says that when you're multiplying two numbers with the same base, what you do is that you keep the base and then you add the powers. So let's use it now. We are multiplying 2 power negative 4 with 2 power negative 2 power 5, positive 5. So you can see that the base is the same, which is 2. So if you work out this using the laws of indices, it will be the same as having 2, keep the base the same. Since we are multiplying, we just add the powers. So this will be 5. So if you add that, you end up getting negative 4 plus 5 will give us 1. So it is 2 power 1. So our answer is 2 power 1, which is the same as 2, which is the same as 2. So here we've used the laws of indices. So if you want to do it the other way around, then if you want to do it the other way around, of course, 2 power negative 4. 2 power negative 4 means 1 out of 2 power 4 multiplied by 2 power 5. This is when you don't want to use the laws of indices, but I'm teaching you how to use the laws of indices to help save you from this long route. So this here you'd say 2 times 2 times 2 5 times. Of course, that's what 2 power 5 means. Times 2 divided by 2 4 times. Multiply 2 4 times. 2 times 2 times 2 times 2. So then you'd start crossing one by one, one by one, one by one, one by one, and you end up remaining with 2. So instead of passing through all these steps, instead of using these long steps here, that's why we are bringing in the use of the laws of indices to save us from writing all these steps, but instead we use the simplest or the shortest method. So let's look at the second one, which asks us to simplify m power 5 power 2. So which law? This law, this time, this is putting us to task to use this law, which says if you have something like this, keep the base and then multiply the powers. So let's do that. So this one here, when we use the laws of indices, it will be the same as, or the solution will be m5. You just multiply the 5 with the 2, and the answer becomes m to the power of 5 times 2, which is 10. That is the answer. Very simple answer. Simple and very simple. But if you use the other way, which most of you like using, this one here, any number squared means you multiply that number twice. So if it is m power 5 squared, then you multiply m power 5 twice. So if I use the other way, or the other long formula, which I'm trying to help you avoid, it will be the same as m power 5 multiplied by m power 5. And this would be the same as m power 5. Now, if you reach here, you can also apply the multiplication law. You can also apply the multiplication law, which says when you're multiplying, you keep the base, and then you add the powers. And this will be 5 plus 5. Of course, it is m to the power of 10. M to the power of 10. Any questions so far? Any questions, or we look to the other example? Iniza, Tobisi.
Yes, sir.
Any questions? Any questions?
No, sir.
Okay. So let's continue.
Yeah, let's proceed. It's clear.
Okay, let's proceed. So we move on to the next example, which is here. So this one here, it asks us to multiply these two. So we bring in something that we call, so here we shall bring in something that we shall call collecting of like terms. Collecting of like terms. So when collecting like terms, we bring factors that are the same together, or we bring what is the same together. So when we bring what is the same together, when answering this, we shall also apply the laws of indices along the way. So this one here is the same as having 4. I'm going to bring the real numbers together, that is the 4 and the 5. I bring the x's together, and then I bring the y's together. So I'm going to bring this one with this with this. Then I bring these ones together here, and then I bring the y's also together. So if I bring the 4 and the 5 together, it will be 4 times 5. Then I bring the x together, it will be times x power 3 multiplied by x power 2. And then I bring the y's together, times y multiplied by y. So I've brought the x together, the y together, and the 4 and 5 together. So when you work out this, 4 times 5, you end up getting, so what happens after this is that you solve the things, you solve the ones which are alike together. So I'm going to solve the x's alone, the y's alone, and then the 4 and 5 alone. 4 and 5 alone. So if I go ahead, 4 times 5, this will give me 20. This will give me 20 multiplied by x power 3 times x power 5. This is the same as, now we bring in the law of multiplication. When multiplying same base, we add the powers, and then I come to this one. Any number without a power means that that number is to the power 1. So for example, if I give you y, it's the same as having y to the power 1. If I give you x, it is the same as writing it as x to the power 1. So if I have a y here, it is the same as having y power 1. So meaning that this is y power 1 and this is y power 1. Since I'm multiplying, I add the powers, so it will be y power 1 plus 1. So if I go ahead, I'll have 20 multiplied by x power 5 multiplied by y power 2. So this will be 20 x power 5 y power 2. So this is our answer. That's our answer. Any question on this example? Any question on this one?
No questions. It's clear to me.
Yes?
It's clear to me, sir.
Okay. Let's look at the next one. So please, I know you have your books and your notebooks. So I'll ask you to do for me number 3, and you tell me the answer. Number 3, what is the answer?
X to the power 10.
Yes?
It's x to the power 10.
The power 10. Okay. So which is got by x by multiplying 2 and 5 using the laws of indices, which will give us x to the power 10. Okay. So let's look at this one. What does this one mean? What does this one mean, Tobisi? What does this one mean?
It means that the answer is 1.
Which answer is 1?
Like when you say x, I say 6 w to the power of 0
Yes,
to 1.
is equal to 1. That's what it means. Okay, nice try, you. But any number to the power of 0 means that that number is equivalent to 1. So for example, if I give you a number as x to the power of 0, this is the same as 1. Even if it is 100, but to the power of 0, this is the same as 1. Even if it is any number to the power of 0, that is always equivalent to 1. So if I give you 6w to the power of 0, this means that you're multiplying 6 with the w to the power of 0. But remember, any number to the power of 0 is 1. So this is the same as having 6 multiplied by 1, because w to power 0 is equivalent to 1. So this is the same as 6 times 1, which is 6. Any questions here? Any questions?
I have a question, sir.
Yes, ask.
Yes, sir.
Yes, ask, I'm listening.
I have a question. Like, then the final answer,
The final answer is 6.
6.
Yeah, bo.
Okay, I see. It's very
So where is the answer is here? The answer is here, it's 6. This one here was wrong. This one here was wrong. This one is wrong, please. Don't take this. Okay. Any question? You're on and off.
Clear.
Yes? Any questions? I'm not hearing what you're saying.
no, sir.
Okay, let me continue. So we have a question down here which says 5x to the power of 3 divided by, minus 3x to the power of 3. So how do we simplify this one? 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 Please, Giniza, give us a clue. Giniza, give us a clue. Any clue, Giniza? Giniza, do you have any clue?
Say 2x to the power 3.
I said 2x to the power 3.
3.
So that is the answer. Okay, so let's look at how he got the answer. So to get this answer, we first do what we call factorization. So factorization is where you determine or you look for what this one has and then what this one has. Look at what this one has and then what this one has. So you realize that all the two numbers have x to the power 3. So I remove the x to the power 3 and put it outside. So if I remove x to the power 3 from this one here, I'll only remain with 5. And if I remove x to the power 3 from this one here, I'll only remain with 3, with 3 only. So if you go ahead to work out this, you'll have x to the power 3 multiplied by 5 minus 2, 5 minus 3, which is 2. So finally, 2 times x to the power 3 is 2x to the power 3. And that is our answer. So next example, the next example, I'll ask Nintendo to tell us what we do on the next example down here, the next question. Nintendo, we are waiting for you. And we are waiting for you. And I'm waiting for you to give us a clue.
No, you have to pay. You thought George picks from the station.
Okay. Since he's not responding, let's go ahead. Let me go ahead and explain. So we are using the multiplication. So we first bring the things that are the same together. So this will be 3. This will be equivalent. Please always put equal signs. I bring the 3 and the 5 together, and then I bring the y's together times y to the power of -2. Then I go ahead, 3 times 5, this is 15. I go ahead and work out these together. And then I also work out these 2 together. So if I work out these, this is the multiplication law. The base is the same. We add the powers. So this is 6 plus -2. So we end up getting 15 multiplied by 6 plus -2 is the same as 6 minus 2. So 6 minus 2, which is 4. So finally our answer is 15y to the power of 4. 15y to the power of 4. That is our answer. That is our answer. 6 plus -2. Okay, so I'll ask Mtobisi to tell us what this one means. Mtobisi, what does this one mean here? Yes.
As a fraction.
Yes, write it as a fraction.
1 over 5 to the power 3.
Yes. 1 over
to the power 3.
Pardon.
5 to the power 3.
5 to the power.
1 over 5 to the power 3.
Okay. Then expand 5 to the power 3. It will be 5 multiplied by 5 multiplied by 5. And finally, this will be, what is 5 times 5 times 5? Is it 125 or 225? Tobisi, what is 5 times 5 times 5? Tobisi, I'm waiting for the answer. 5 times 5 times 5?
250.
5 times 5 3 times is 250. Please check your calculator. I think it's 125. 125. 125. Okay. So Hendo is off again. So I want Giniza, the next question. Write for us this one in standard form.
I also need help, sir, here. I don't understand.
Which one? Part B. Part B. Giniza, part B.
I don't understand, sir.
Okay. Oh, standard form.
I also need help, sir.
Okay. So when they say standard form, it means that you write the number with one number at the rate, leaving a whole number at the rate. Leave a whole number at the rate. I think you can see that there is a zero. There is a zero before the decimal point. But in standard form, they mean that write it with only one number, which is a whole number at the rate. So this means that this is zero, this is zero. So make sure that you write when you only leave the first whole number is 4. So it means you write when leaving 4 as the whole number before the decimal point. So meaning that we have to move this decimal point